All right, good afternoon. About to do tutorial 8. All right, so we're going to do tutorial sheet 8, log future. All right, so tutorial sheet 8 is basically more on the binomial expansion. Okay, so I think that's what we're going to focus on. Now, before I can even start the binomial, there are things that most of you may not know, so I'll try to do the binomial in such a way that even if you've never seen binomial before, you can still do it. Okay? So MSN 111. Alright, so the first thing I want us to introduce is this. What is n factorial? Okay, so what is n factorial? Basically speaking, when we talk about n factorial, then what I'm referring to is this. N factorial is n multiplied by n minus 1, n minus 2, n minus 3, and so on. Okay, so that is what n factorial is all about. For example, let's say what you're given is 4 factorial. So what would be 4 factorial? So 4 factorial will be, the first one is n. So n here is 4, multiplied by n minus 1. This is subtract 1 from n minus 1. So you've noticed that 4 minus 1 is 3. Then 3 minus 1 is 2. 2 minus 1 is 1. It ends there. Okay? So this basically becomes 4 times 3 is 12. 12 times 2 is 24. Okay? So that's what we get. Alright, so we can continue with that. The next thing that I would want to introduce is this. Alright, so assuming that you've been given n choose r, okay, by definition, n choose r is n factorial over n minus r factorial r factorial. So we pronounce this as n combination r. On your calculator, I think you should have a c and be n like that, okay? It's a function which is written down on calculator. So we're saying n choose r is given as n factorial over n minus r factorial, r factorial. These comma dots, the exclamation mark you're seeing there, we pronounce it as factorial. Okay, so that is what we have. Now, let's assume you've been given a question, 5 choose 3. So what is n in this case? N is 5. Okay? Then what is r? R is 3. So what is 5 minus 3? 5 minus 3 is 2. Okay, then what is r? R is 3. So that is that. So consider this as example 1. Then part 2. Example 2, let's say you've got 7 choose 4. So if you've got 7 choose 4, what would be 7 choose 4? What would be 7 choose 4? 7 choose 4 will basically be, n is 7. Then what's 7 minus 4? So n minus 4, n minus r. Since n is 7 and r is 4, so it's 7 minus 4, which is 3 factorial. Then what is r? R in this case is 4, so that's 4 factorial. Okay? Let's consider example 3. let's pick a bigger number. Let's say 12 choose 5. 12 choose 5 will actually be 12 factorial, because n is 12, over 5 factorial, so that's n. 12 minus 5 is what? 7. Then 5 factorial. Okay, so that's how you go about those questions. Now, what if you are taught to find the exact value for 5 choose 3 and you don't have a calculator? How do you use that? So let's do this. We're talking about 5 choose 3. So basically 5 choose 3, if you check, we say it is 7 factorial over 3 factorial 4 factorial. That's what we found here. Now we know that 7 factorial can be written as 7 times 6 times 5. So what I'm going to do is I'm going to write this in that form, but I'll end where the largest in the denominator. Well, I'll end at the largest in the denominator. So what is the largest in the denominator in this case? The largest in the denominator is 4, alright? So that means that I'm going to end at 4. So this is going to be 7 times 6 times 5 times 4 factorial. Okay, because the largest number in the denominator is 4. Over, then I'm going to say 3 factorial forward factorial. I did that so that because this is multiplication, this and this will cancel, right? But what do we know? We know that 7 times 6 times 5 over what is 3 factorial? 3 factorial is 3 times 2 times 1. Now, what is 3 times 2? 6. So meaning this and this will cancel. So 7 times 5 is what? 35. That's the answer. Okay, let's evaluate the other one as well. 7 choose 4. 7 choose 4, we said it was 7 factorial over 3 factorial 4 factorial. Okay, so what's the largest we have in the denominator? Again, it's 4 factorial, so we have 7 times 5, 6, 7 times 6 times 5 times 4 factorial over 3 factorial multiplied by 4 factorial. Okay? Then you have 4 and that will cancel. Then as I said before, we know that 3 factorial is 3 times 2 times 1. 3 times 2 is 6, so this and this will cancel. What's 7 times 5? Again, 35. It's interesting. Notice that 5 choose 3 has given us the exact same value as 7 choose 4, right? And the reason is simple, all right? I'll show you. Let's go to another one. Five choose 3 can actually be written as 5 factorial over, what's 5 minus 3? 2 factorial, okay? So I'll not do this question. Let's consider the last one. 12 choose 5. Choose 5. Choose 5. 12 minus 5, 12 factorial over 12 minus 5 is 7 factorial. Okay, then we have 5 factorial. Because this is n minus r, that's 12 minus 5 with 7, and we have r, which is 5 factorial. Now, the largest number in the denominator is what? The largest number in the denominator is 7. So because of that, what we're going to do is we're going to say 12 times 11 times 10 times 9 times 8 up to 7. Okay? Over 7 factorial times 5 factorial. Then this and this can cancel. But we know what 5 factorial is. 5 factorial is 5 times 4 times 3 times 2 times 1. Okay, so we know 5 can go with 10, so that's 2. Then these 2 can cancel with these 2, alright? Then we know that 3 can go into 9 3 times. Then we know 4 can go into 12 3 times. Okay, but basically I know some of you may have wanted to say instead 4 into 8. So let's say 4 into 8, so it should be 2. Alright, so now we have 12 times 11 times 3 times 2. This is 12 times 3 times 2 is 6. 6 times 11 is 66. Okay, then 12 times 66 is what? So 12 times 66, we will end up having 792. Right? 792. Remember, it can be done here. 66 times 12. 2 carry 1. That is 12. 13. 6. Yeah. So we have 12. 2 carry 1. That is 12 plus 1. 13. Then we have 1 times 6, which is 6. Then 1 times 6, which is 6. So you notice that 792. Alright, so that's how we get to the 792. Just doing that multiplication from the 5. Okay. And now where is it? That's how we came up with 792. Alright, so with that brief introduction, we can now do a question that is similar to that in tutorial sheet. So let's go to tutorial sheet 8. Alright, so let's go to tutorial sheet 8. Right, so we can now do a question in tutorial sheet 8. So this was just a recap, okay? It's the foundation so that you know exactly how to do the question in tutorial sheet 8, okay? So tutorial sheet 8. Alright, so I'm certain that for some of you it's written tutorial sheet 7, okay? So some of you it's written tutorial sheet 7. So we are talking about binomial expansions for those that just joined us. Alright, so we have a question here. It says 9 choose 3 plus 10 choose 6 plus 9 choose 2. Okay, so now remember what we said? We said n choose r, we know is n factorial over n minus, so n minus r factorial, so 9 choose 3 would be 9 factorial over 9 minus 3 is 7 factorial, 3 factorial plus 10 choose 6 is 10 factorial over 10 minus 6 is 4 factorial, 6 factorial, plus 9 choose 2, that is 9 factorial over 9 minus 2. Okay, so 9 factorial over 7 factorial, 2 factorial. Okay, so from this now, what you need to consider here is what is common. Now remember, I can actually write this to make sure that everything there reflects something that is common. Okay, so in doing that, what I'm going to do is we're going to say 9 factorial over, if you notice that the denominator here, you've got 7 factorial, 3 factorial, right? 4 factorial, 6 factorial, then you've got 7 factorial, 2 factorial. So you can actually make everything here look similar so that we are actually able to factorize anything that is common. So how do we make this look similar? For us to make it look similar, we're going to consider what is the lowest and what is the largest. Okay, so the lowest here, you'll notice that it's actually 2 factorial. Okay, then what's common in the numerator? 9 factorial, 9 factorial. Then we know that 10 factorial can actually be written in the form of 9 factorial as well. Okay, so we're going to do that. So let's start with the numerator. Plus, what is 10 factorial? Remember, we talked about this as n factorial is actually n minus 1, n minus 2, and so on, right? So 10 factorial can be written as 10 times 9 factorial. Okay, so meaning where there's 10 factorial, I can say 10 times 9 factorial. Okay, then from here, what we're going to now do is, I'm just dealing with the numerator, plus 9 factorial. Okay, let's now write the denominator in the same form. So we're saying, writing the denominator in the same form, we're going to have, this is 7, the largest. Here there's no 7, so it's not possible. Of course, 7 here, 7 here. So it's not possible for us to have 7 here. Okay, you can reduce, but you cannot increase. Okay, so I'm saying that as if you noticed, 5 factorial is 5 times 4 times 3 times 2 times 1. Okay, notice that the numbers are actually reducing minus 1. Okay, 5 minus 1, 4. 4 minus 1, 3. 3 minus 1, 2. 2 minus 1, 1 with 8 there. Okay, so if you have 8 factorial, this is 8 times 8 minus 1, 7. 7 minus 1, 6. 6 minus 1, 5. 5 minus 1, 4. 4 minus 1, 3. 3 minus 1, 2. 2 minus 1, 1. Okay, so we end there. So this is just what these factorials are doing. Okay, so when you see this exclamation mark, it's factorial. What does it mean? You are multiplying the first, which is the n, multiplied by the one before it, multiplied by the one before it, until you reach the last number, which is 1. Okay, so this is how we generally go about these factorials. Now, after you do that, the next thing now is you now have the general idea of what I'm about to do. Okay, so I know that I cannot shift 4 or 6 to 7, but I can reduce 7 to 6. Okay, so the largest here, which is common, is actually 6 factorial. You will see that 7 factorial is the same as what? 7 multiplied by the one before it, 6 what? Factorial. Then multiplied by 3 factorial. So let's write it like this. Okay, then what is this one? Will maintain it. Now, this we're going to write as 4 factorial multiplied by 6 factorial. Then I can write this again as 7 multiplied by 6 what? Factorial times 2 factorial. So this 7 factorial I've written it as 7 times 6 factorial, then multiplied by the 2 factorial here. Okay? In the same way, this is what I did. This 7 factorial, I wrote it as 7 times 6 factorial times 3 factorial. Okay? Now, what's the smallest here? If you check, the smallest is 2 factorial. So now, we have 6 factorial common, 6 factorial common, 6 factorial common. So now we need this smallest to be amongst this, because you know 3 factorial is the same as 3 times 2 factorial, 4 factorial is the same as 4 times 3 times 2 factorial. Let me write that so that you see. So I'll say 9 factorial, okay, over 7 times 6 factorial times 3 times 2 factorial. Can you see that? So 3 factorial is 3 times 2 factorial, okay? Plus, we have 10 times 9 factorial over 4 factorial can also be written as 4 times 3 times 2 factorial, that's 4 factorial, 4 times 3 times 2 factorial, okay? Remember, where the factorial ends, it means there's still numbers that you can go decreasing like that. Okay. Then plus 9 factorial over 7 times 6 factorial times 2 factorial. Alright? So basically speaking, I've rewritten the 3 factorial as 3 times 2 factorial, and I've rewritten the 4 factorial as 4 times 3 times 2 factorial, but remember there's what here? The 6. So times 6 factorial should reflect, okay? Then we have this one, I've maintained it because we have 7 times 6 factorial times 2 factorial. So if you look at this now, what is common? The first thing that is common is what? 9 factorial, okay? Then what else is common? You will notice the 6 factorial here, 6 factorial here, 6 factorial here. So I'll write this as 6 factorial, okay? What else is common? You've got 2 factorial here, 2 factorial here, 2 factorial here, so we have 2 factorial, okay? What has remained? Here the numerator has remained as 1. Here, what is the denominator? The denominator is 7 times 3. Plus, here what is the denominator? The numerator has remained as what? 10. What is the denominator? The denominator has remained as 4 and 3 because we factored out 2 factorial and 6 factorial. So 4 times 3. Okay? Then plus, what is 9 factorial? We factored it out. So what has remained? 1 over what is in the denominator. We factored out 6 factorial and 2 factorial, so what has remained in the denominator is 7. Okay, so from this, I'll write it here, 9 factorial over 6 factorial, 2 factorial. So what's the common denominator here? The common denominator from this, let me erase up to this part. why I write it here. 9 factorial over 6 factorial 2 factorial. What's the common denominator here? The common denominator is, you see, there's 7, 3, 4, 3, 7. So 7 is common. What else is common? There's 3. Sorry, there's 4, then there's 3. Right? So 7, 4, and 3. I mean 7, 4, and 3. These are the common, that's the common denominator which you have. So now, 7 by 3 into 7 by 3. So what? Okay, hope you can see that. Okay, so a recap on this part. So here we say we have 7 times 6 factorial times 3 factorial. I just factored out the 9 factorial over 6 factorial 2 factorial. Okay, when I factored it out, here what remains? 7 times 3, which is here. Okay, then here I factored out the 6 and 2, what remains? 4 and 3. There I factored out 7 by 6, this what remained was a 7. Okay, so now we're saying this is a common denominator. When you divide times 1, you end up having 4 plus this is 70 plus 7 here, so it's 12. Okay, so basically that's what you get. That is what you have as the final answer. Okay, so I just want to do a bit of some erasing. Okay, so basically speaking, this is where we are thus far. Now, remember that the question is telling us that we need to leave our answer in the form n choose r. So that is our target, in case you are wondering what is the direction of what we are doing. So basically speaking, that is what we have. Okay. Okay, so I just want to continue from here. Over. Let me erase this for a bit. So for those who are just coming in, this was the question. N choose 3 plus 10 to 6 plus 9, 2. Okay, so that's what we basically had at the question. Then from there we said this actually 9 choose 3, this is 9 factorial over 6 factorial over 3 factorial. Okay. Then from there, we have a different component of the question. We have a different component of the question. Nine factorial over this, so plus. Now we said 10 can be written as that over 10 minus 6 is 4 factorial, then 6 factorial, then 9 factorial over 7 factorial, 2 factorial. Okay? Then from here, what we said was we have 9 factorial over. Now we said we are going to actually rewrite this in such a way that we have the same thing which is common from there, so we have 6 factorial. Then this part will end up being multiplied by 2, 3 times 2 factorial, okay? Then plus 10 multiplied by 9 factorial over, this is going to, remember we are saying we want to change this to make it have a 2 factorial. So this is what we did. Then plus 9 factorial over 7 factorial. So 7 can be rewritten as 7 times 6 factorial times 2 factorial. This is 2 factorial, which is already here. Then we said what is common here, so we had to factor out what was common. So what was common was 9 factorial over 6 factorial, 2 factorial, okay? If I factor out, this is common, this is common, this is common, 2 factorial here, 2 factorial here, 2 factorial here. So 6, that. What remains? There's also in the numerator, there's 9 factorial, 9 factorial, 9 factorial. So we are now going to have 1 over, this part here is going to be, what is going to remain? We're going to have a 3, okay? Plus, what is going to remain here? We're going to have 10, if we remove the 9 factorial, over, here we're now going to have 4 by 3, okay? Then plus, the next thing that we're going to have is 1 over 7. So look at this, I factored out 9 factorial throughout and I've factored out 6 too, okay? Then what's the common denominator here? The common denominator there is 3, 3, 4, and 7. So it's 7 times 4 times 3. 3 into 3, that's 7 times 4 is 28, plus 4 by 3, that's 7 times 10 is 70, plus 7 into that is 7, that is 12, okay? Right, then from here, we're going to have 9 factorial over 6 factorial, 2 factorial, multiplied by 12 plus 28 is 40, plus 70 is 110, okay, over 7 times 4 times 3, okay. Then from here, what we're going to have is hope it's visible. From here, what we're going to now have is we're going to split these two, 9 factorial multiplied by, what is 11 times 10? Two numbers that you can multiply to give you 110, 11 and 10, okay? It's visible from there. Then we have the denominator now being equals to 6 factorial, 2 factorial, 7 times 3 times. Okay, now I'm going to rewrite the denominator, okay, because I'm multiplying. So this we're going to maintain it. Remember, this is 7, 10, then this is in brackets. 7 times 4 times 3. Then 6 factorial, 2 factorial. Okay? So you have 6 factorial, 2 factorial. Then from there, what we're now going to have is we're going to check. We're going to rewrite this product, okay? Rewriting this product, we're going to have 11 times, I'm arranging in descending order, okay? Then again, I'm going to write the denominator also in descending order. So the largest there is 7, followed by 6 factorial, then followed by 4, by 3, then by 2 factorial. So I've just rearranged this. So we're saying the largest here is 7, so it's 7, then 6, 4, 3, 2 factorial. Okay? But what do you notice? You notice that from this, the numerator here was 11 times 10 times 9, right? Doesn't this look like a series? This is actually 11 factorial. Over, what is the denominator there? 7 times 6 factorial is what? 7 factorial. What is 4 times 3 times 2 factorial? This is 4 factorial. So I'm saying 11 times 10 times 9. Remember that n choose to n factorial? Write it from here. So we have 9 factorial over 6 factorial 2 factorial. So I'm rewriting it from this point so that you see, in case you have some reflection. Okay, so I'm starting from that point. Then I said I'm going to multiply this in descending order. So this is 11 times 10 times 9 factorial. Okay, over this is going to be 7, the largest number, times second largest is 6 factorial. What's the third largest? 4. Next largest is 3. Then lastly 2 factorial. Okay, it's the same thing this side. I'm just writing it there for clarity in case you're unable to see clearly this side. Okay, so I'm saying here, if you remember what n factorial by definition is, n factorial is n minus 1, n minus 2, and so on, right? So when you look at this, this is 11. Then after 11, 10. After 10, 9. After 9, 8. But there's one here, a factorial, meaning that the 9 is still descending from 9 to 8 to 6. So I'll put a factorial just to end there. So now 11 times 10 times 9 factorial is actually 11 factorial. Over. Doesn't this also look like a series? 7 times 6 factorial. This is like 7 times 6 times 5 times 4 and so on. So 7 times 6 factorial is like saying 7 factorial, right? Because 7 factorial can be found as 7 times what? 6 factorial. Right? This is the same thing. So now, instead of writing 7 times 6 factorial, I've written it as 7 factorial. Doesn't this look like a series as well? 4 times 3 times 2 factorial. So 4 times 3 times 2 factorial is actually 4 factorial. Don't you agree? Okay, so we have, I'll write it here. We're saying 4 factorial is what? 4 times 3 times 2 times 1, right? But 2 times 1, this can be written as 2 factorial. Remember that whenever you see the factorial, it means those values are actually descending, they keep descending, okay? So those values keep on descending. That's how it works. Okay, so basically that is that. So I erase this part. Now, by definition, look at this. This is actually the same as n. What is n minus, what's 11 minus 4? 7. Then 4 factorial. So this is actually 11, choose 4. Choose 7. Or 11 to 7. So that's your answer. So if someone writes 11 choose 4, or someone writes 11 choose 7, both of you have the same answer. Alright? So we're saying 11 minus, remember the definition? The definition, n choose r is given as n factorial over n minus r factorial r factorial. Okay? So here, it's like you have 11 here, then the difference is 7, then the r is 4, right? So if you say 11 choose 4, what is 11 choose 4? So n is 11, right? 11 minus 4 is what? 7. Then 4 factorial, so this is that. Or you could have had 11 choose 7. 11 choose 7, 11 is n, which is here. Then 11 minus 7 is what? 4. Then 7 factorial. Okay, so it's the same, one and the same. So this is how you get to the answer. Okay. That ends that question. Okay, next up. So you are told to find the expansion for x, 3x minus 4y, the power 4. We're looking for that expansion. How do we expand that? Okay, so in general, x plus y, the power n, is found as x to the power n plus n choose 1, x n minus 1, y plus n choose 2, x to the power n minus 2, y to the power 2, plus the formula to my head. So we're saying x plus y, the power n, is equal to x, the power n plus n choose 1, x to the power n minus 1y, plus n choose 2, x to the power n minus 2, y squared plus n choose r, okay, x to the power n minus r, y to the power r, and it continues, okay, up to y to the power n. So generally speaking, that's the standard formula for a binomial expansion. Okay? That's the general formula for a standard expansion. Alright, so I want to use this formula based on this. So what is x? X is 3x and the y part is 4. What is n? N is 4. So meaning that x, 3x minus 4y, if we're expanding this, this is going to be 3x to the power 4 plus 4 choose 1. Then we have 3x, 4 minus 1 is 3, then negative 4y, okay, plus, next up, we have 4 choose 2, then we have 3x, the power. Now we are saying n minus 2. So 4 minus 2 is 1? 2. Then negative 4y to the power 2. Now what you will notice is that here, when you add the power of x and y, they will always get you back to n. Because n minus 1 plus 1, the ones will cancel, you end up getting back to n. N minus 2 plus 2, back to n. N minus r plus r back to n, okay? So even here you notice that as we continue writing the expansion, you notice that the power of this component here, the variable here and the variable here, add up to 1. So here there's 3 plus 1, it adds up to n. So n is 4 in this case. So you have 3 plus 1, which is 4. You have 2 plus 2, which is 4. So the next one, plus, you have 4, choose 3, okay, then we have 3x, the power 3, then negative 4y. Now it has reduced. Instead of having it's n minus 3, so this is going to be 1, then you are going to have 3 here, okay, then plus n choose 4, which is 4 choose 4. So I'm replacing the n with the 4. So 4 choose 4. 3x to the power. So now 3x is now to the power 0. Then you have negative 4y to the power 4. Okay? So basically speaking, that is the general expansion. That's the general expansion. Okay, so now, how do we work around that expansion? From here, we're going to say what is 3 squared, 3 to the power 4. That's probably 24. So 3 times 3 times 3 times 3. So this is 9 times 9. So the answer is 81. Okay. So we have 81 x to the power 4 plus, what is 4 choose 1? 4 choose 1 is simply 4. Then we have, notice that we have numbers multiplying here. So 4 choose 1 is 4 times 3 to the power 3 is 27 times 4. Okay, so this is the same as 27 multiplied by 16, which we have 7 times 16 is basically 42, because 7 times 7 is 49, so 42, this is 12 plus 4, 16, 7, 2, 7 plus 6 is 13. This is 3 plus 1, 4. 432. So we have 432. Now notice there's a sign here, so it's minus xy. Okay? Next, I'm dealing with a different expansion now. I'm looking at this component. So what is 4 choose 2? 4 choose 2, that's 4 factorial over 2 factorial, 2 factorial. This is 4 times 3 times 2 factorial over 2 factorial times 2 factorial. So this and this will cancel. So 2 into that, that is 2, so that's basically 6. So we are now here. So this is the same as saying 6 times 3 squared is 9 times negative 4 squared is 16, positive 16. So 6 times 9 times 16. In this case, we can still do the multiplication of 6 times 9 times 16. Okay? If you're calculating, you should have 864, right? So plus 864. Okay, now one thing that we need to consider is when we're dealing with this one, what is the power of x? X to the power 3. Okay, so that's x to the power 3. So 864 from here, x squared, y squared. Plus plus the next part we now need to do is this part. So what is 4 choose 3? 4 choose 3 will be 4 choose 3 is 4 factorial over 4 minus 3 is 1, then 3 factorial. So this is 4 times 3 factorial over 3 factorial. This and this will cancel times 1 factorial. Okay, so we have the answer is 4. Right. So 4 choose 3 is simply 4. Then from there we're going to say 4 times 3. Okay, multiplied by 4 to the power 3. Now 4 times 4 is 16, multiplied by 4 is 64. Okay, so 64. So we're now looking for 12 times 64. $778. Alright, so that is what we have 778. Okay, so 7. So this is 8. 4 times 1 is 5 plus 1. That's 4 plus 1. That's actually 4. Okay, so this is 8, this is 4. 6 times this is 12, 2 carry 1. That's 6 times 1, 6 plus 1, 7. 8, 6, 768. Okay, so we have 768 x, then y to the power 3, but because of the sign, this is actually minus. Okay, plus minus. Then the last one, we have this part here. Now, what you should know is n, choose n, will always be 1, n choose 0 will always be 1. Okay, so we're saying n choose n will always be 1 and n choose 0 will always be 1. So in short here, we're just looking for 4 to the power 4, which is the same as saying 16 by 16. So we're saying 16 because remember I have 4 4s. So this is 16 by 16. This is 6, 3, 9, 6, 1, 6. This is 15 to 56. Okay. So plus 256 y to the power 4. So that's the expansion. (256 y to the power 4). Okay, so basically that's how you expand 256 y to the power 4. Okay? Alright, so we have that. Let's now look at the last question. I could have done this using also a different formula or by the method of Pascal's triangle, okay, but we're not going into that. So let's just do one question, then we end the tutorial. So the standard formula for this is usually found under what is called the extension of the binomial. Alright? You have 1 plus x to the power n. This is given as 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 2 over n minus 1, n minus 2 over 3 factorial x to the power 3 and so on. Alright? So assuming that we're doing question 5, so question 5, you've been taught to determine the value of the following correct to 5 significant figures. So you have 0.98 to the power 7. Alright, so we're trying to use the binomial expansion to find the answer for that without using a calculator. So how do we get to that? So 0.98 to the power 7, what do we do? So now, you know that 0.98, right, can be rewritten. So I'll give you first, we'll talk about the expansion for this so that you know exactly what we are looking at. Okay, so for us to actually get to 5 significant figures, we have to first reckon what this will be in standard form. So now, remember 0.98, how did they get to 0.98? For them to find 0.98, they must have subtracted from something. So let's go to the nearest whole number. So I'll say 1.0 minus 0.98. 98. Okay, like that. So we can get a 1 from there. So that we have 10, 9 here, 1. Then you notice 0 .10 minus 8 is 2, 9 minus 9 is 0. So meaning that they must have subtracted 0.02 from 1 to get to this. Okay, so we're saying for them to get to 0.98 to the power 7, what they did was they said 1 minus 0.02. Okay, if you subtract 1 minus 0.02, we are just from doing it, so 1.00 minus 0.02, you notice that this is actually 9, 1. 10 minus 2 is actually 8, 9 minus 0 is 9, yeah, then 0.0, so 0.98, you see? So this is how they got to this. So now what we're going to do is, we are saying this is the same as the power 7, okay? So now what I want to do is I'm going to write this in form of a fraction so that some people can really understand how I can generalize that, right? So I'm going to write it in form of a fraction. So this is 1 minus 2 over, now 0.2 is the same. What did they do? They divided by 100. There are 2 decimal places, right? They are power 7. Okay, so this now looks exactly like this. The only thing is that this is plus, but for it to be minus, it means it's this thing which is minus. So wherever there is n, I'll be putting 7, and wherever there is x, I'll be putting this, because from here you can see this is 1, this is 1, then x is this part. Okay, so we have 1 plus n is 7. What is x? Negative 2 over 100. Alright, then plus 7, 6, because 7 minus 1 is 6, over 2 factorial, then we have negative 2 over 100. Then we have square. Okay? Then lastly, because it's 5 significant figures, I'll end up with x to the power 3, because I know if you raise 0.02 to the power 4 or 3, that's already 6 significant figures. Okay, so I'll end up to where it reaches the power 3. Okay, so that's how far we are going to go with that expansion. Alright. So, which is the next number? So the next number that we have here is 7 times 6 times 5 over 3 factorial, then negative 2 over 100 to the power 3. Okay? So that is best done when you decide to go the fraction way. So I'm going to write 1 minus 2 over 100 here, power 7 is equals to 1, this is minus 14 over 100. Alright, now we know 2 factorial is what? We know that 2 factorial is actually 2. So 2 into 6 is 3. 3 times 7, 21. But there are other numbers here. What is 2 squared? 2 squared is 4. So this is the same as saying 4 times 3 times 7. 4, 2 squared is 4. So 4 times 3, 12, 12 times 7, 84. So meaning we are going to have, because this is squared, so plus 84 over, what is 100 times 100? So this is actually 10,000. Then next, we know that 3 factorial is the same as 3 times 2, 6 times 1. So it's just 6. So 6 into, so this and this can cancel, okay? Then we have 2 to the power 3 is 8. So we are now saying 8 times 5, which is 40. Then we are saying what is 40 multiplied by, from here, 2 to the power 3 is 8. 8 times 5 is 40, 40 times 7. This is actually 28, so 280. So we have minus, because negative to the power 3 is still negative, so minus 280 over 100 to the power 3, okay? So now that is just the same as 1 million, because we have, okay? So that is 1 million. Can we change this back to decimals? So changing back to decimals, we have 1 minus, so this is going to be 0.14 plus, here we're going to have 0.084 plus, here we're going to have 0.1234. Okay, so 1, 2, 3, the first 3, then we have 280. Then I'm going to add the numbers here. So if I'm going to arrange them, so let's just do addition first. So we're saying 1 point plus 0.084 plus 0.123 280. Okay, so I can add zeros here, can add zeros here. That's all someone. Okay, so what's happening? 0, 8, 2, 4, 8, 0.01, because 1 plus this. Okay, so this is 1.084 280. Okay, so we have 1.0824280 minus 0.14, so minus 0.14, because it's the only one with the difference. So we have 0.824, 8 minus 4 is 4, 0 minus 1, you can borrow 1 from there, 10, then you have a 9 point, here 0, okay, so that's your final answer. So we have 0.944280. So if you count 1, 2, 3, 4, 5, so this is what we have as our answer. So this is what 0.98 to the power 7 is. Okay, so I've managed to find 0.98 to the power 7 without the use of a calculator. I've managed to find that without the use of a calculator. Okay, so basically this is all I had for you under binomial. Okay, remember to go through, subscribe, so that, remember, those that subscribe have got notifications whenever we are online. Okay, may never know, maybe your friends may delay to post the link in the group, but if you are subscribed, then it will be easy for you to get the notification direct to your phone for those that are usually online. Alright, so have a good day. End of tutorial.